Welcome to Space Dreams documentary. Arcturus, ancient giant star, reveals what waits for suns like ours. Tonight, familiar orange landmark hangs peacefully above darkness, while age quietly rewrites everything hidden inside. Arcturus seems fixed and calm, yet its swollen glow reveals the destiny awaiting stars like ours. It matters not because it shines nearby, but because stellar age has transformed an ordinary star. Brightness becomes a disguise, letting deep time hide inside a sky object people mistake for permanence. Arcturus looks powerful through size, yet its true meaning begins with age and fuel already spent. The first real crisis comes when the core can no longer burn hydrogen with former stability. Once that hidden failure begins, the star still shines, but its inner balance starts slipping away. Now gravity tightens the core, raising heat and forcing the outer layers into a larger form. Arcturus swells not in victory, but because late survival demands an envelope around a tightening core. Its gentler color suggests softness, yet enormous size lets this cooler star radiate astonishing power. From that orange calm, the lesson widens, because one giant star can preview an ordinary sun. Arcturus becomes more than itself here, showing that suns like ours are heading towards similar change. As giant phases begin changing light, and radius start rewriting every world that circles nearby. Even friendly star systems carry an ending, because long habitability fails once warmth turns into excess. To understand that future, we must remember Arcturus before grandeur, when it looked almost ordinary. Arcturus matters because this giant once lived quietly as a less dramatic and more ordinary star. Mass sets the pace, deciding how quickly stars burn, transform, and limit the time around them. The deeper ending is prolonged upheaval, because stars like Arcturus reshape worlds before any remnant appears. After giant glory fades, the vast star leaves a compact remnant and returned material drifting outward. Arcturus is a visible warning, proving time can turn familiar starlight into the future of suns. Please like, subscribe, and thank you for listening, because Arcturus already begins where familiar stillness deceives. Arcturus looks like the kind of star that should mean permanence. It rises in the northern sky with that deep orange steadiness, bright enough to command attention and calm enough to suggest that whatever shines like this must have found a lasting equilibrium. But that surface impression is almost the opposite of the real story. Arcturus is not important because it is stable. It is important because it is no longer what it used to be. The star people see as a fixed beacon is actually a late chapter in a much larger transformation. And what makes it extraordinary is that it reveals in visible form a future that stars like the sun cannot avoid. The familiar night sky hides this well. Human beings are too short-lived to watch stars truly change, so the mind quietly translates constancy into permanence. A bright star appears in the same broad place for a lifetime, and instinct treats it as an unchanging object. But a star is not a landmark. It is a system under pressure. It is a temporary balance between inward collapse and outward release. It survives only by spending itself. And that means every star carries two stories at once, the story of what it is now and the story of what its present state is costing it. Arcturus is where those two stories begin to separate so dramatically that even across vast distance, the difference becomes visible. On the surface, it is easy to summarize. Arcturus is the brightest star in Bootes and one of the brightest stars in the night sky. It is relatively nearby by stellar standards, and its warm orange color makes it easy to distinguish from harder white or blue stars. For centuries, it has drawn attention simply because it is there. Yet the obvious explanation is not the real one. Arcturus does not matter because it is one more bright point among many. It matters because that orange light is the signature of a star that has already crossed a boundary the sun has not yet reached. It is not merely shining. It is unveiling a stage of stellar life that turns ordinary longevity into structural upheaval. This only looks simple from a distance. The story on the surface is that Arcturus is a giant star. The story underneath is that giant stars are not born giant. They become giant because something in the old arrangement begins to fail. For most of a star's long adulthood, hydrogen in the core fuses into helium. Energy released by that process pushes outward while gravity presses inward, and the star maintains a hard-won truce between collapse and expansion. It can last for billions of years. It can seem eternal from the viewpoint of planets and civilizations beneath it. But the truce is not peace. It is expenditure. A star survives by burning the conditions that let it survive. The more quietly it shines, the more deeply it is spending the future that once seemed secure. That is the first hidden truth inside Arcturus. It is not ancient merely in the flattering sense. Its age is physical. Its history is written into its present structure. The star has already used enough of its central fuel that the old stable arrangement cannot continue in the same way. What you are seeing in Arcturus is not maturity in the human sense. It is the visible consequence of interior change that no eye can directly observe. And because stars conceal their deepest events behind their own light, the transformation announces itself indirectly. The color changes. The radius swells. The brightness rises into a new register. The star becomes easier to see precisely because something fundamental has become harder to sustain. This is where the scale of the story begins to widen. Arcturus is larger than the Sun, brighter than the Sun, and cooler at its surface than the Sun. That combination sounds contradictory only if one imagines brightness as a simple product of heat. But stars do not work by surface impression alone. A cooler surface spread across a vastly larger area can radiate immense power. So Arcturus glows with that softer orange tone, not because it has become weak, but because its outward form has changed so profoundly that gentler color and greater luminosity now exist together. Arcturus is not a hotter sun. It is a star whose whole architecture has shifted. Its enormous visible body is evidence that late stellar life is not a neat decline. It is a reorganization. It is the old order losing its grip and a new one forcing its way outward. The Sun does not look like Arcturus now. It is smaller, younger in evolutionary terms, and still spending its hydrogen in a more stable way. But the real problem is not whether the Sun resembles Arcturus today. It is whether the logic that created Arcturus also governs the Sun. And the answer is yes. Not in every detail, not at the same pace, but in the deeper sense that matters most. Stars like the Sun do not escape aging because they seem steady. They age through steadiness. The very balance that makes life possible around them is also the mechanism through which their future giant phases are prepared. Every calm sunrise on Earth belongs to a star that is on the longest timescale, moving toward a crisis of structure. That future is unimaginably far away by human standards, but it is already built into the system. Arcturus makes that hidden fact visible now. It stands in the sky as proof that stellar security is temporary, that radiance can be a symptom of exhaustion, and that the serene lights above us are not suspended outside time. The deeper you look, the less Arcturus resembles a decorative star, and the more it resembles a message. It says that stars do not remain what they are. It says that longevity is not preservation. And once that idea takes hold, the star stops being a distant orange lantern and becomes a preview. Because if Arcturus is not simply bright but transformed, then the next question is no longer what it looks like. The next question is what exactly had to begin failing inside a once ordinary star to make such greatness possible. Arcturus is bright enough to invite the wrong conclusion. A star that dominates the sky so easily can look like a winner, a celestial heavyweight whose importance begins and ends with sheer visibility. It is one of the first stars many people learn to pick out warm orange unmistakable strong. But brightness is often the least revealing fact about a star. The eye notices prominence. Physics asks why that prominence exists now in this form at this moment of the star's life. And that is where Arcturus stops being a simple landmark and becomes something far more valuable. It is not merely a bright object above Earth. It is an exposed phase of stellar aging close enough and clear enough to let us see what a once ordinary star becomes after billions of years of internal spending. The obvious story is that Arcturus matters because it shines so powerfully in our sky. The real story is that it shines this way because its old arrangement has already been broken and rebuilt. That distinction changes everything. Seen from Earth, Arcturus feels immediate. It lies only about 37 light-years away, which is nearby in galactic terms, and that proximity is one reason it appears so prominent. Distance matters. A great many stars are more intrinsically luminous, but they are so remote that they dissolve into anonymity. Arcturus does not. It is close enough for its present condition to become visible as experience rather than abstraction. Its orange light is not a technical entry in a catalogue. It is a direct encounter between a planet orbiting a middle-aged star and another star that has already moved beyond middle age. In that sense, Arcturus is not just part of the night sky. It is a preview across space. What makes the preview so useful is that Arcturus is not some wildly exotic monster born in the most extreme class of stars. It is not the kind of object that can be dismissed as irrelevant to the Sun because its mass violence or destiny belong to another category entirely. Arcturus is more disciplined than that. Its significance comes from being close enough to the broad family of sun-like evolution to illuminate a future that feels uncomfortably related to our own system. Not identical, not immediate, but structurally connected. This is why the star deserves more than admiration. It deserves interpretation. Arcturus is classified as an orange giant, which already signals a life stage rather than just a color. It has expanded far beyond the Sun's present size, and despite a cooler surface, it radiates well over 100 times more total energy than the Sun because its surface area is so vast. That is the first correction to the shallow view. A star can look softer and still be far more luminous overall. A cooler color does not mean retreat. It can mean enlargement on a scale so large that the star's gentler light is merely the outer skin of a much bigger engine. Arcturus teaches this almost immediately. It forces the mind to abandon the easy habit of treating stars as glowing bulbs whose brightness is just a matter of heat. Surface appearance can conceal a deeper rearrangement, and in Arcturus, the rearrangement is the whole point. There is another reason the star matters. Arcturus has long been known for a noticeable motion against the background of more distant stars. The significance is simple, even before the details are technical. This is not a decorative pin fixed onto a cosmic ceiling. It is a body with history, origin, and fate. It belongs to the Milky Way, not as a static light, but as a participant in the long circulation of stars through the galaxy. That matters because once a star is granted motion, it becomes harder to imagine it as timeless. A moving star implies a past different from the present. It implies formation somewhere, evolution through time, and a future that will not resemble what we see now. Arcturus helps break the ancient illusion that the sky is made of eternal fixtures. It reminds us that celestial stability is often a trick of human timescale. Yet even motion is not the deepest layer. The deeper layer is age. Arcturus appears powerful because it is large and luminous now, but those traits are not the whole explanation. They are consequences. A younger star with the same mass would not look like this. Arcturus matters because it shows what time does to stellar order. This is why its brightness is so misleading. Brightness feels like a statement about present strength. In Arcturus, brightness is also a statement about accumulated history. The star is older than the sun, and what we are really seeing is not just current output, but the visible result of fuel already consumed, equilibrium already altered, and internal options already narrowed. That is the second correction to the shallow view. When people look at Arcturus, they are not simply seeing a successful star. They are seeing a star that has already spent enough of its central inheritance to leave the old life behind. That makes Arcturus valuable in a way a younger main sequence star is not. It lets astronomy turn time into sight. No one can watch a star age in real time across billions of years. But nature offers substitutes, stars caught at different stages, each preserving one chapter of a larger process. Arcturus is one of those chapters written in unusually readable form. It is bright enough to command attention, near enough to study, well-evolved enough to reveal the consequences of stellar aging, and familiar enough to resist being dismissed as a rare curiosity. The story on the surface is smaller than the story underneath. On the surface, Arcturus is a beautiful orange giant near Earth. Underneath it is evidence that a star can spend most of its life appearing stable, while quietly preparing a future that looks nothing like its calm beginning. And once that becomes clear, brightness no longer feels like the main question. The real question is how old a star has to become before its light stops telling the story of what it is and starts revealing the cost of everything it has already burned through. Arcturus looks immediate, but its real subject is time. That is the next correction. Human eyes see brightness and color in the present tense, yet stars carry their past inside their present form so completely that what appears to be a simple object is really a long accumulation of vanished conditions. Arcturus is powerful now, but its current power is not the beginning of its meaning. Its meaning begins with age. Not age as a poetic label. Age as a physical transformation, measured in fuel-consumed balance, altered structure, reorganized, and possibilities closed off one by one over spans of time so large that ordinary intuition fails before the numbers even settle in. This is why Arcturus is more revealing than it first appears. It is not merely a giant star. It is a star whose present body is built from earlier losses. The obvious explanation is that Arcturus became large because giant stars are simply large by nature. The real explanation is harsher. Stars become giants because they cannot remain what they were. A star's longest stable phase depends on hydrogen fusion in the core. As long as that central engine holds, gravity is resisted in the most direct and efficient way the star possesses. But no star is granted infinite access to that arrangement. Hydrogen in the core is not a permanent foundation. It is a finite reserve. The star lives by reducing it. So the quiet brilliance of a star's adult life is not evidence of endless continuity. It is evidence of controlled depletion. Arcturus has already moved far enough through that depletion that its old central order no longer defines the whole star. That is what age means here. It means history has begun to overpower the original design. Arcturus is estimated to be older than the Sun, with an age often placed at around 7 billion years. The number matters, but not because large numbers are automatically impressive. The number matters because it places Arcturus on the far side of a threshold the Sun has not yet crossed. The Sun is roughly 4.6 billion years old, and still in its long main sequence adulthood, still fusing hydrogen in the core in the relatively stable pattern that has governed nearly all of Earth's biological history. Arcturus is not. Whatever its exact path and initial mass, it has already progressed into a later regime of stellar life in which the old certainty is gone. That is why the star's orange giant form matters so much. It is not a decorative variation on a normal star. It is evidence that time has accumulated enough power inside the system to force the system into a new state. And stars do not make that transition lightly. This is the point where human language can mislead. Old things are often imagined as diminished things. In everyday life, age suggests slowing, shrinking, weakening, the gradual loss of outward force. But stars are not human beings, and stellar aging is less like quiet fading than like delayed structural consequence. A star may spend billions of years in disciplined equilibrium, and then enter a stage where age produces enlargement. Luminosity changes deep interior instability and consequences for everything nearby. Arcturus is older than it looks precisely because it looks so grand. Grandeur is not a denial of age here. It is one of age's products. The star's immense visible form is not the preservation of youth. It is what happens when youth can no longer be preserved. This is why the phrase giant star can hide more than it reveals. Giant sounds triumphant. Ancient sounds resigned. Arcturus is both, and the combination is the truth. It is large because it is past the easy part. It is luminous because the old internal economy of the star has already begun to fail in its original form. And once that point is reached, the star's current appearance becomes a record of past consumption. Every widened layer, every shift in color, every increase in overall radiative output points backward to fuel already spent in the hidden interior. The star is not merely old in years, it is old in consequences. The Sun will one day face the same kind of accounting. Not now, not soon by human standards. But eventually the long interval of main sequence steadiness ends, and what seemed like a durable middle condition is exposed as temporary after all. Arcturus allows that future to be seen in advance because its current state is the visible answer to a question that the Sun has not yet been forced to answer. What happens when the central arrangement that defined a star's stable life can no longer remain the whole story? That question is already written across Arcturus. The answer is not immediate collapse. It is not sudden disappearance. It is transition through enlargement, through altered brightness, through a body that announces that the interior has crossed a hidden line. The star's age is therefore not some passive background fact. It is the engine of relevance. Without age, Arcturus would be one more bright star. With age, it becomes an exposed future. It reveals that stars do not merely shine and then stop. They pass through chapters in which the past reworks the present, in which billions of years of quiet expenditure return as visible transformation. And that is the deeper shock. Arcturus feels serene because we see only the finished surface. But serenity here is a late effect of long internal spending. The star's current magnificence is made of earlier loss. Its beauty is the shape time takes after fuel begins to run out in the place that once mattered most. Which means the next layer is no longer about age alone. It is about the concealed turning point that age eventually creates, the moment when a star's core can no longer keep doing the one thing that made the rest of its life possible. The great change in a star's life begins in a place no eye can see. When people imagine stellar aging, they imagine the surface first, the color warming the body, swelling the light-changing character. But those are consequences. The turning point happens much deeper down inside the core, where a star's long, stable life depends on one central arrangement continuing to work. For billions of years, that arrangement looks almost invincible. Hydrogen in the core fuses into helium. Energy released in that fusion pushes outward. Gravity presses inward. The star holds. From the outside, this can look like permanence, because the timescale is so vast that even civilizations appear and vanish without changing the impression of stability. Yet the real problem is not what the star looks like while this balance lasts. It is what happens when the core can no longer keep producing energy in the same way. That is the quiet failure inside Arcturus, not an explosion. Not a collapse visible across the galaxy, a hidden loss of the old method. And once that begins, the rest of the star is forced into a new future. This is why the giant phase is so deceptive. It feels dramatic, but the deeper drama has already happened before the star ever looks giant at all. A star like Arcturus spends most of its life on the main sequence, where core hydrogen fusion defines the entire structure. The core is the command center. It is where pressure, temperature, and nuclear reaction rates are high enough to maintain the outward flow of energy that resists gravity. As long as hydrogen remains abundant enough in that central region, the system can regulate itself with discipline. If gravity squeezes slightly harder, the core heats up, fusion rates increase, and the added energy pushes back. If the core expands slightly, it cools, fusion slows, and gravity regains leverage. This feedback makes main sequence stars seem dependable on immense timescales. But feedback is not immortality. It is management of a finite reserve. Hydrogen in the core is being converted into helium the whole time. The star is not keeping a steady state for free. It is buying stability by consuming the material that made stability possible. Billions of years pass. Helium ash accumulates in the center. The region capable of efficient core hydrogen fusion changes in composition and contracts in importance. Eventually, the star reaches the point where the old central engine no longer governs the system the way it once did. For a star in this mass range, the issue is not that all hydrogen everywhere is suddenly gone. The issue is that the core itself can no longer continue its original hydrogen-burning role. That distinction matters. The star is not empty. It is structurally compromised. Its deepest source of direct resistance has weakened, and gravity immediately notices. This is the second hidden truth in Arcturus. Gravity never leaves. It waits. During the long, stable phase, fusion and pressure keep it from redesigning the star. Once the core hydrogen era ends, gravity begins to reclaim authority in the center. The inert, helium-rich core contracts under its own weight. As it contracts, it heats up. That heating does not restore the old order. It creates the conditions for a new and more complicated one. Around the contracting core, hydrogen in a surrounding shell can ignite and fuse more intensely than before. This is one of the key reframings in stellar evolution. The star does not move from working to dead. It moves from one arrangement of nuclear burning to another, and the transition changes everything above it. What matters is not the event itself, but the system beneath it. Core failure does not simply reduce the star. It reorganizes where energy is generated, how it flows outward, and how the star's layers respond. The shell burning around the core can pour energy into the overlying layers so effectively that the outer envelope swells to enormous size. This sounds backward at first. Why would the failure of the core lead to a larger star? Because the old compact arrangement is no longer the only way to maintain outward pressure. Once the site of energy production shifts, the outer layers are pushed into a new equilibrium at vastly greater radius. The star becomes bloated cooler at the surface and far larger overall. Giant status is not the continuation of normal life. It is the visible architecture of internal disruption. Arcturus embodies that disruption now. Its orange light-enlarged body and changed luminosity are the outer symptoms of a crisis that began in silence. This is why stars are so hard to understand intuitively. In ordinary experience, failure means shrinking capacity and reduced reach. In stars, the failure of the old core regime can produce expansions so immense that the star becomes more luminous overall and vastly larger in size. The achievement is real. The cost is larger. A star in this phase can look grander than ever, precisely because the simple arrangement of its adulthood is over. The surface spectacle is the result of interior limitation. The larger body is what late survival looks like, not what uninterrupted success looks like. And this is where Arcturus becomes more than a single case. The Sun still lives in the long middle chapter Arcturus has already left behind. But the physics is not optional. Stars like the Sun do not negotiate with the exhaustion of core hydrogen. They are governed by it. What Arcturus shows now is a future in which central certainty gives way to layered burning structural rearrangement and swelling outer consequence. That is why the true turning point in a star's life is so easy to miss. It happens beneath the surface, long before the sky announces it. By the time the star has become visibly giant, the decisive loss has already occurred. The old core order has failed. Gravity has begun to rewrite the center. New burning has flared in a different place. And the outer star, forced to obey interior change, starts becoming something immense. Which means the next question is no longer whether Arcturus changed. The next question is how gravity, once given that opening, turns a hidden failure in the core into one of the largest transformations a star like this can undergo. Gravity does not destroy a star all at once. That is what makes it so dangerous. People imagine catastrophe as a sudden event, some violent celestial failure in which a star can no longer resist and immediately collapses into ruin. But for a star like Arcturus, gravity is more patient than that. During the long main sequence years, it is held in check by the energy released from hydrogen fusion in the core. The star looks settled, but only because gravity is being paid off continuously by nuclear burning. Once the old core regime begins to fail, gravity does not simply win in one clean movement. It begins to redistribute power inside the star. It takes control of the center first. And that shift in control drives one of the strangest results in stellar evolution. The deeper the core contracts, the more the outer star can expand. This looks backward until the mechanism becomes visible. The obvious explanation is that a giant star is large because it has somehow grown stronger at the surface. The real explanation is almost the reverse. The center becomes harsher, denser, and more compressed, and the outer layers are forced outward in response. The star becomes immense because gravity has tightened its grip where the eye cannot see. After core hydrogen fusion ends, the helium-rich center is no longer generating enough energy in the old way to hold itself up in the same stable pattern. Gravity presses inward. The core contracts. As it contracts, gravitational energy is converted into heat-raising temperatures in the surrounding regions. That heating matters because the shell of hydrogen outside the inert core can now burn more intensely than before. The star has not solved its crisis. It has changed the location of the fight. Energy production shifts away from the center and into a shell wrapped around it, and that shell pours huge amounts of energy into the overlying stellar envelope. The result is not a compact star working harder. The result is that the outer layers lose their old scale and begin moving outward to a radically different equilibrium. In effect, the star's interior becomes more divided. The core contracts and hardens. The envelope loosens and swells. One part falls inward. Another part is driven outward. The object remains one star, but it no longer behaves like the simpler star it used to be. This is one of the great hidden reversals inside Arcturus. The surface grandeur is born from interior asymmetry. The star is becoming more layered, more unequal, and more dependent on a tense arrangement in which the core and the envelope are no longer living the same kind of life. The core is moving toward hotter, denser, more extreme conditions. The outer layers are becoming diffuse, extended, and far less tightly bound. Gravity creates both outcomes at once. It compresses the middle and through the altered flow of energy helps inflate the outside. That is why Arcturus is so instructive. It shows that stellar aging is not a straight decline. It is a reconfiguration in which the center and the surface stop telling the same simple story. The center is becoming more desperate. The surface becomes more majestic. This is also where the meaning of balance changes. In an ordinary main sequence star, the balance between gravity and pressure is relatively direct. The core burns hydrogen energy flows outward, and the whole star settles into a compact regime that can last for billions of years. In a giant star, the balance still exists, but it has become more complicated and more fragile. Pressure now depends on burning in a shell around a contracting core. The envelope responds by expanding so far that its surface cools even while the total luminosity rises dramatically. This is why Arcturus glows orange instead of white-yellow like the Sun. Its surface is cooler, but the star is so much larger that its overall energy output remains vastly greater. The eye sees warmth and softness. Physics sees the aftermath of deep internal strain. If the Sun was somehow replaced by Arcturus in its present form, the giant radius of Arcturus would extend far beyond the orbit of Mercury and deep into the inner solar system. That scale matters because it exposes what giant really means. We are not talking about a star that is somewhat larger than the Sun. We are talking about a star whose outer body has been pushed outward on a planetary system scale. And that is not a decorative enlargement. It is structural consequence. The star's atmosphere is more weakly bound. Its surface gravity is lower, and its outer layers are easier to disturb and eventually easier to lose. The old, tight star is gone. What remains is a swollen, luminous and increasingly vulnerable outer envelope wrapped around a core moving in the opposite direction. The achievement is real. The cost is embedded in the architecture. This is the larger pattern Arcturus begins to reveal. Gravity is not the enemy of stars only at the end. It is the permanent rival inside every stage of stellar life. During youth and adulthood, fusion keeps that rival from remaking the star too quickly. During later life, as fuel conditions shift, gravity regains initiative and starts forcing the star into new forms. Arcturus is one of those forms. Its giant body is not a denial of gravity. It is gravity's long strategy made visible. The star expands because the core has already been forced into contraction. It cools at the surface because the same luminosity is now spread across a vastly larger area. It grows more impressive in the sky because the hidden contest inside it has entered a more consequential phase. That is why a giant star should never be mistaken for a simple, larger version of a normal star. It is a star whose old, compact life has been broken open by deeper pressures. And once that becomes clear size, itself stops looking like an answer. It starts looking like a warning. Because if Arcturus is enormous, not through permanent triumph, but through late-stage rearrangement, then the next layer of the story is not about how beautiful that expansion appears from Earth. It is about what expansion really means for the star, for the worlds that might circle it, and for the future, waiting inside every seemingly stable sun. Arcturus looks calmer than the sun, and that is exactly why it is so easy to underestimate. Its orange light feels gentler than the harsher white-yellow glare associated with hotter stars, and human instinct tends to read gentleness as weakness. A cooler-looking star should be giving off less power. A softer color should mean a smaller engine. A warm orange beacon should not be outshining a younger, hotter star by such a wide margin. But that instinct breaks down the moment stellar scale becomes visible. The obvious explanation is that hotter stars are always more powerful. The real explanation is that total power depends on more than heat alone. It depends on how much surface is radiating that heat into space. And Arcturus has so much surface that its cooler outer layers still release vastly more energy overall than the Sun. This is one of the deepest visual corrections the star forces on us. Color tells part of the truth. Size tells the rest. Without both, the eye invents the wrong physics. The Sun's surface is hotter than that of Arcturus. On temperature alone, the Sun seems superior. It burns with the kind of brightness human beings associate with intensity, while Arcturus glows in a deeper orange, more often linked with evening fire, old metal or embers after a hotter flame has passed. Yet that comparison becomes misleading the instant it remains trapped at the surface. A star radiates energy across its entire visible area, not from one representative patch. If one object is somewhat cooler but enormously larger, the total energy leaving its surface every second can exceed that of the hotter object by a huge factor. This is why Arcturus matters so much as an educational shock. It teaches that a star can cool at the surface and still become more luminous overall. The star has not become less consequential because its color has softened. It has become more consequential because its body has expanded so profoundly that gentler radiation spread across an immense area turns into extraordinary output. That is not an optical trick. It is the visible signature of a new regime of stellar life. In physical terms, luminosity scales with both surface area and temperature. Raise temperature and a star becomes much more radiant. Increase radius and the surface area grows enormously. In Arcturus, the temperature is lower than the Sun's, but the radius is so much larger that the total result is a star radiating well over 100 times the Sun's energy. This is why giant stars are so conceptually dangerous to intuition. They scramble the shortcuts the mind wants to use. The star looks cooler, therefore perhaps dimmer. The star looks softer, therefore perhaps weaker. The star looks less fierce, therefore perhaps less important. Every one of those reactions fails. Arcturus is telling a larger story than appearance alone can hold. Its orange color is not a retreat from significance. It is one piece of evidence that significance has been reorganized. The old, compact, hotter surface of a main sequence star has given way to a huge envelope radiating at lower temperature, but on a scale so vast that the total power becomes immense. This is the larger reframe. The star's softer face belongs to a bigger machine. And that machine changes the meaning of visibility itself. A star like Arcturus is not merely bright because it is close. It is bright because its present life stage combines high intrinsic luminosity with relative proximity. It reaches human eyes not as a technical object, but as a dominant presence. For ancient skywatchers, that meant a notable star. For modern astrophysics, it means something more useful, a nearby example of how stellar output changes when the old central order is gone and the envelope has swollen into giant proportions. The brightness in our sky is not an isolated fact. It is the local expression of a deep structural transformation. What we receive as orange light on Earth is the end product of everything hidden beneath it. Core contraction, shell burning envelope, expansion, altered temperature, huge radiating area. This is why the story on the surface is smaller than the story underneath. Surface color feels like the whole identity of the star until luminosity forces a correction. Then the correction itself opens another door. Because once a star can be cooler and still much more luminous, the consequences stop being merely theoretical. Greater luminosity means the surrounding space is being flooded with far more energy. It means habitable zones shift outward. It means planets that once orbited safely can be overheated, stripped, destabilized, or engulfed depending on distance and timing. It means giant phases are not quiet cosmetic changes. They are system-wide events. Arcturus is not just an orange light in the sky. It is a demonstration that stellar aging can increase the danger to nearby worlds, even as the star's visible tone becomes softer. The contradiction is exact. The surface looks calmer. The consequences become larger. This matters especially because human imagination often treats the sun as the standard against which all stars should be measured. Hotter than the sun means more extreme. Cooler than the sun means less severe. Arcturus ruins that simplicity. It shows that a star can leave the main sequence cool at the surface and still become far more powerful in total output than the sun currently is. The comparison is uncomfortable because it shifts the lesson from astronomy to fate. Arcturus is not just some orange giant doing giant star things somewhere else in the galaxy. It is evidence that stars in the broad family of sun-like evolution do not become harmless as they age. They become different, and that difference can involve a dramatic increase in the amount of energy they pour into surrounding space. Once that point is understood, Arcturus stops looking like a picturesque elder among the stars. It begins to look like a warning written in warm light. Because if a cooler-looking giant can still radiate such immense power, then the next question is no longer how Arcturus manages this contradiction. The next question is what that contradiction reveals about the future of the sun itself, and how far a star must change before its worlds realize that the age of gentle stability is over. The most unsettling thing about Arcturus is not what it is what it implies. A giant orange star can still be filed away in the mind as something safely other, a beautiful elder from a category far removed from the Sun, interesting but not intimate. That is the comfortable mistake. The real value of Arcturus begins when distance stops meaning irrelevance. It is not a mirror of the Sun in every detail, and it should not be forced into that role. Arcturus is somewhat more massive, older in its evolutionary progress, and shaped by its own specific history. But the deeper pattern it displays is one the Sun cannot refuse. Stars of this general kind do not remain in their long middle age forever. They exhaust the simple order that once sustained them. Their cores change, their envelopes expand, their luminosities rise into new regimes. Their surrounding systems are rewritten. Arcturus matters because it lets that future be seen before it arrives here. The obvious explanation is that the Sun will stay sun-like for so long that the later phases barely deserve emotional weight. The real explanation is that the later phases are the entire point of stellar finitude. A star can spend billions of years appearing dependable and still be moving toward a transformation, large enough to erase the conditions that once made its worlds feel permanent. The Sun is about 4.6 billion years old. It remains in the stable hydrogen-burning chapter that has powered Earth's climate and biology for nearly the whole history of complex life. It will continue in that broad state for billions of years more. On human timescales, this sounds like safety beyond imagination, and in one sense, it is. No civilization planning in centuries or millennia needs to fear the Sun becoming a giant star. But this is where timescale becomes a trap, because the security is real only when measured against human life. It is not real in the deeper structural sense. The Sun is not exempt from the same underlying physics that made Arcturus possible. It is living inside the same bargain. It is fusing hydrogen in the core. It is converting one internal order into another. It is spending the future to maintain the present. Every second, enormous quantities of hydrogen in the solar core are turned into helium. This is the price of daylight. It is the hidden exchange beneath every season, every ocean current, every living cell fed directly or indirectly by sunlight. The Sun's calm authority is built on continuous consumption. That is why Arcturus should feel so close conceptually, even while it is so far away physically. Arcturus is what happens when the reserve that once made calm possible reaches a more advanced stage of depletion. The star swells, the color shifts, the luminosity changes, the compact life of adulthood is over. The Sun is not there yet, but its future is not open-ended. One day, core hydrogen fusion will cease to define the center in the old way. The Sun's core will contract. Hydrogen burning will continue in a shell around that core. The outer layers will be driven outward. The radius will grow enormously. The luminosity will rise. The present inner solar system will not survive unchanged. That does not mean the Sun will become Arcturus in every quantitative sense. Stellar evolution is not a copy and paste process. Initial mass matters, composition matters, rotation age and detailed interior physics matter. Arcturus is a guide, not an exact portrait of the Sun's final giant appearance. But the guide is enough. It shows the broad logic of what awaits. The Sun will move from being a compact, relatively stable main sequence star to a swollen red giant whose increased luminosity and vast radius transform the architecture of its planetary system. That is the real bridge between the two stars. not sameness of detail, sameness of fate at the level that matters most. The stable chapter ends. The outer star expands. The worlds nearby pay the cost. This is where the story stops being astronomical in a detached sense and becomes existential. Earth exists inside a narrow interval of stellar history. Life has emerged under a sun that has been steady enough, long enough for chemistry to become biology, and biology to become awareness. But that steadiness is not the permanent character of our star. It is one chapter. A long chapter, yes. A generous chapter, yes. But still a chapter. Arcturus reminds us that stars do not owe their planets an eternal middle age. They carry a schedule written into mass and fuel from the beginning. The Sun's future giant phase is not a possibility waiting to be decided. It is an outcome waiting for enough time. Even before the full red giant stage arrives, the Sun's gradual brightening over immense spans will alter Earth's conditions long before engulfment or terminal expansion become relevant. The deeper truth is that habitability is temporary even under a well-behaved star. The age of ocean's weather and biological abundance depends on a limited thermal window. Arcturus stands beyond that window. It is not hosting the kind of calm that allowed Earth to become Earth. It is showing what comes after calm. This is why its orange light carries such weight. It is not only the light of an old star, it is a future tense written into the sky. It tells us that what feels a fundamental in a planetary system may only be a middle condition. It tells us that the Sun's apparent reliability is inseparable from the fuel it is steadily removing from its own core. And once that truth is accepted, the meaning of Arcturus changes again. It is no longer merely a giant star that resembles the Sun's future in broad outline. It becomes evidence that every stable sun hides a deadline, and that the most consequential transformations in a star's life are not reserved for exotic monsters, but for the ordinary stars around which worlds like ours are built. The transformation of a star is never confined to the star. That is the next illusion Arcturus destroys. It is easy to picture stellar evolution as a private event, a drama sealed inside the star's own layers while the surrounding system waits at a respectful distance. But planets do not orbit abstractions. They orbit changing sources of gravity, heat radiation, and wind. When a star leaves the calm, compact regime of its adulthood and enters giant phases, the event is not local. It is systemic. The star's altered structure becomes a new environment for everything around it. That is why Arcturus matters in a deeper way than simple stellar biography. It is not just showing what happens to a star. It is showing what happens to worlds when the power at the center of their system begins to age out of equilibrium. The obvious explanation is that planets are mostly passive spectators to stellar aging until the final dramatic stages arrive. The real explanation is harsher. By the time a star looks unmistakably transformed, the conditions for nearby worlds have already begun to shift, sometimes irreversibly. The old habitability, the old climate, the old balance of light and distance and chemical stability do not remain in place while the star changes. They are among the first things to be rewritten. The simplest reason is luminosity. As stars like Arcturus leave the main sequence and swell into giant forms, their total energy output rises dramatically. Even without the star touching a planet physically, the amount of energy bathing that world can increase beyond anything its old atmosphere, oceans, or geology were built to manage. A planet does not need to be swallowed to be ruined. It can be sterilized, desiccated, chemically altered, or stripped of whatever made it stable, long before engulfment becomes relevant. The image of danger arriving only when the star's surface physically reaches outward is too late stage to capture the real sequence. The real problem begins when the star starts flooding its system with a new thermal reality. In our own solar system, this is the future encoded inside the Sun. Long before the Sun reaches its maximum red giant size, Earth's habitability will already be in crisis because rising solar output will intensify, heating, disrupt the carbon cycle, threaten the long-term stability of the oceans, and drive the planet beyond the window in which surface life as we know it can survive. Arcturus shows that this kind of progression is not fantasy. It is the normal consequence of stellar evolution at work. The star does not need malice. It only needs time. But luminosity is not the only force changing the rules. As stars expand into giant phases, their outer layers become more loosely bound. Surface gravity weakens. Stellar winds can intensify, carrying mass away into surrounding space. This matters because a planetary system is not held together by light alone. It is organized by the mass and behavior of the central star. When the star begins shedding material, even gradually, orbital relationships can shift. The architecture of the system is no longer perfectly anchored to the old conditions. The star that once ruled its planets through a relatively stable combination of mass and radiation becomes a changing source of both. This widens the meaning of danger. The threat is not only overheating, it is systemic destabilization. Atmospheres can be eroded. Radiation environments can change. Distances that once corresponded to one climate regime begin mapping onto another. The old map of safety is gone. This is where Arcturus becomes especially powerful as a lesson. A giant star looks majestic from outside because expansion reads as grandeur. But for anything orbiting such a star, grandeur is not the right word. Exposure is. A star's swollen outer envelope and elevated luminosity do not create a richer version of the previous system. They create a harsher one. The wider the star becomes, the more inner orbital space is occupied, irradiated, and transformed. Mercury-like worlds disappear first. Venus-like worlds do not survive as they were. Earth-like worlds fare no better simply because their destruction may arrive by overheating before direct engulfment. The sequence may differ from system to system, but the governing truth remains: once a star begins giant evolution, the old contract with nearby planets is broken. This is why the common image of stars as life-givers needs a second half. A stable main sequence star can indeed sustain biospheres over immense spans. But the same star also carries the mechanism that will eventually end that stability. Life under a star is not a permanent gift. It is an interval. Arcturus is what it looks like when the interval is over. Not for every possible world at every possible distance. Because giant systems can have outer regions, newly warmed and previously frozen bodies shifted into different thermal zones. But that kind of secondary opportunity should not obscure the central reality. The inner order that once defined the system is finished. Whatever calm once existed close to the star is gone. The system is not entering a richer maturity. It is entering a phase of forced rearrangement in which old worlds pay for the star's interior transition. The story on the surface is about stellar enlargement. The story underneath is about the expiration of planetary normalcy. And that is the real reason Arcturus should not be viewed only as a beautiful sky object. It is a warning against local arrogance. Earth feels permanent because human beings experience only a brief and unusually favorable slice of solar history. But the larger physics does not care about that feeling. Planetary comfort is contingent on a star remaining inside a certain regime. And that regime does not last forever. Arcturus has already crossed beyond it. Its light reaches us as evidence that stars eventually become dangerous to the very kinds of worlds they once might have sustained. Which means the next layer of the story is larger still. Because if the transformation of a star rewrites the fate of its planets, then the comforting idea of a habitable system itself begins to fail. The real problem is not one unlucky world near one aging star. It is that habitability everywhere may be less like a permanent state and more like a temporary permission granted by a star that is already moving toward its own end. Habitability feels like a property of a planet. That is the comforting mistake. A world has water or it does not. An atmosphere is thick enough or too thin. Temperatures stay within the right range or drift beyond it. From that point of view, life seems to depend mainly on local conditions, on geology, chemistry, and maybe some good fortune. But a habitable world is never only a local achievement. It is a temporary arrangement between a planet and a changing star. The atmosphere can be right, the water can be present, the chemistry can be rich. None of it survives if the central source of energy moves outside the narrow regime that made those conditions possible. This is the harder truth Arcturus helps expose. The real problem is not whether a planet can become habitable. It is whether that habitability can last. And in stellar terms, lasting does not mean forever. It means only for as long as the star remains inside a phase that allows it. The phrase habitable zone sounds reassuring because it suggests geometry. Put a planet at the correct distance and the problem seems solved. Too close and water boils away. Too far and it freezes. Somewhere in between lies a belt of possibility. That framing is useful, but it is also incomplete in a way that matters profoundly. A habitable zone is not a fixed ring painted permanently around a star. It moves. It drifts outward as the star's luminosity rises over time. Even during the long main sequence chapter, stars like the Sun do not remain perfectly constant. They slowly brighten as core conditions change. That means the belt of temperate conditions also changes. A planet can begin inside the favorable range and later find itself outside it without moving at all. What looked like secure placement turns out to be timing. This is the deeper instability hidden beneath planetary comfort. Worlds do not merely occupy space. They occupy moments in stellar history. Earth is a case study in that quiet dependence. The planet's oceans, climate cycles, and biological inheritance can make it feel self-sustaining, as though life here belongs to Earth, because Earth earned it through its own complexity. In one sense, that is true. The planet's geology, magnetic field, atmosphere, and chemistry all matter enormously. But none of those advantages would be enough under the wrong star or under the right star at the wrong stage of its life. Earth is habitable because it exists not only at a suitable distance from the Sun, but during a suitable era of the Sun. Change the time and the same orbit means something else. That is the uncomfortable correction. Habitability is not just a place. It is a phase relationship. It depends on a planet and star being aligned in the right way for long enough, but not too long. This temporal fragility becomes clearer when the future is allowed into the picture. Over immense spans, increasing solar luminosity will drive Earth toward a climatic threshold, beyond which oceans' weathering cycles and atmospheric balance can no longer sustain surface conditions favorable to complex life. That transition begins long before any giant star engulfment scenario. The world does not wait for the Sun to become enormous before danger becomes real. The old equilibrium erodes gradually. First, the margin narrows. Then the feedbacks worsen. Then a world that once sat in the fortunate middle begins to find that the middle itself has moved away. This is why the phrase life-friendly star should always be heard with an expiration date attached. The friendliness is real. The expiration is just larger than human imagination prefers to handle. Arcturus stands beyond that expiration. Whatever worlds may once have orbited it in milder times, the star's present state announces that the old temperate zone has been radically displaced. Its luminosity is too high, its envelope too expanded, its giant star conditions too advanced for the inner calm of a younger main sequence system. The star is no longer offering the same kind of contract to its surrounding space. It is not simply older, it is operating under a different relationship with distance itself. Orbits that might once have meant moderate conditions now imply intense exposure. Inner regions that may once have hosted rocky planets in stable thermal regimes are no longer what they were. The physics has outgrown them. That is the larger lesson. Habitability is not defeated only by dramatic accidents, asteroid impacts, orbital chaos, stellar flares, or atmospheric loss. It is defeated by normal stellar evolution. The greatest threat to long-term planetary comfort may be nothing more exotic than a star continuing to be a star. This should change the emotional meaning of the cosmos. When we speak about life elsewhere, about biospheres around distant suns, about the search for worlds that resemble Earth, the real question is never just where. It is when. A planet in the habitable zone of its star today might have been frozen in the deep past and doomed in the far future. A world comfortable now may be living through its only broad interval of generosity. A system can look stable while already moving toward thermal betrayal. The answer seems clear until the scale becomes visible. Then comfort becomes timing, and timing becomes precious. That is what Arcturus helps reveal. Its orange light is not only the sign of a giant star, it is evidence that every habitable zone is provisional, every life-friendly interval, finite, every apparent refuge, dependent on a central power source whose own history is never standing still. Yet there is an even deeper turn beneath this. Arcturus was not always the giant warning it is now. It had a quieter beginning. It once belonged to the category of stars whose future it now exposes. And that means the next question is no longer how habitability expires. The next question is what Arcturus used to be before age expansion and giant star power rewrote its meaning entirely. Arcturus is easiest to misunderstand when it is treated as though it has always been what we see now. A giant orange star feels complete in its present form, as though its identity begins with largeness, warmth, and late authority. But that impression is another illusion, created by looking at stars only in the chapter they happen to be living now. Arcturus was not born as an orange giant. It did not emerge from its natal cloud, already swollen, already cooling at the surface, already broadcasting the future of stars like the Sun. It began as a younger, tighter, more ordinary star, living under the same basic arrangement that governs long stretches of stellar adulthood across the galaxy. This matters because the present grandeur of Arcturus is easier to admire than to decode. The star looks like a category. In reality, it is a history. And histories are what make giant stars so revealing. The obvious explanation is that Arcturus belongs to a naturally majestic class of stars, whose destiny was always written in spectacular form. The real explanation is narrower and more unsettling. The star we see now is not its original nature displayed at full scale. It is the result of a once more modest structure, being transformed by time, fuel loss, and interior rearrangement. In other words, the giant was built out of the ordinary. That is why Arcturus matters so much for the future of stars like the Sun. If it had always been radically unlike them, it would be easier to admire and easier to dismiss. But Arcturus did not begin as a hypergiant monster or a short-lived blue giant blazing through an alien form of stellar life. It likely began as a somewhat more massive main-sequence star, hotter and whiter than the Sun, but still governed by the same basic principle, hydrogen fusion in the core sustaining a stable outward pressure against gravity. Before the expansion, before the orange glow, before the enlarged luminosity, there was a more compact star with a different temperature, a different radius, and a different relation to surrounding space. This is the crucial reframe. The star's current appearance is not its essence. It is its aftermath. To understand why that matters, it helps to remember what a main sequence star really is. It is not simply a star in the middle of its life. It is a star in the most disciplined phase of its life, when energy production in the core is direct enough, stable enough, and centrally organized enough to hold the whole structure together in a compact regime. That was once Arcturus. For millions upon millions of years, then billions, it would have looked less like a giant warning and more like a star in command of itself. Its light would have been harder, its body smaller, its surface hotter, its place in its own system defined by a more concentrated source of radiative and gravitational order. Whatever planets may have formed around it would not have been orbiting the Arcturus of today. They would have orbited a star whose danger and generosity were arranged differently. This is where the star becomes almost unsettling as a thought experiment. Imagine seeing the current Arcturus and then being told that this immense orange giant was once a more compact main-sequence star living in a much calmer geometry. The mind resists because the scale difference is too large. It feels like two different kinds of objects. But that is the deeper truth of stellar evolution. One star can contain radically different worlds within its own biography. The same object that now floods space with giant star luminosity once occupied a much narrower and more stable regime. The same star that now serves as a preview of solar old age once lived through the kind of long, steady chapter that makes planetary normalcy possible. Arcturus was not always the lesson it is now. It had to become that lesson by surviving long enough for the easy order to fail. This changes the emotional force of the star. It is one thing to hear that all stars evolve. It is another to realize that the bright giant overhead was once a less dramatic object whose future was hidden inside a quiet beginning. Arcturus did not advertise its destiny at birth. Like the Sun, it began in apparent order. Like the Sun, it spent long ages converting hydrogen into helium in the core. Like the Sun, it lived through a chapter that from the outside could be mistaken for permanence. The differences in mass and timescale matter, but they do not erase the continuity. The giant phase did not replace an unrelated earlier star. It emerged from it. This is why looking backward into Arcturus's past matters so much. It reveals that stellar catastrophe is often not sudden and not visibly announced in advance. The largest transformations are prepared inside long stability. The old star contains the new one in potential. The future giant is already there in the ordinary adult star, not as outward appearance, but as stored consequence. Every quiet billion years is part of the construction. Every calm interval is also preparation. The story on the surface is that Arcturus changed from one kind of star into another. The story underneath is that the second form was always being paid for during the first. This is what makes its history so valuable. Arcturus is not just a late-stage star. It is proof that even the more disciplined and familiar chapters of stellar life are temporary arrangements underwriting a far stranger future. The star's forgotten past is not a side note. It is the reason the present carries so much meaning. Because once Arcturus is understood as a former main sequence star, rather than a timeless giant, the distance between its story and the Sun's story begins to feel much smaller, and that opens the next harder layer. If Arcturus once looked more ordinary, then what decides how quickly a star leaves that ordinary state behind is no longer a question of appearance. It becomes a question of mass. The hidden authority that controls how fast a star burns, how long stability lasts, and how soon the bill for all that quiet radiance finally comes due. Mass is the quiet authority behind almost every important decision a star will ever make. That is the next hidden layer beneath Arcturus. Stars can be described by color, brightness, radius, age, distance, motion, composition, and evolutionary stage, and all of those descriptions matter. But beneath them sits a deeper rule that shapes the rest. How fast a star burns, how hot its core becomes, how brightly it shines during adulthood, how long it can remain in stable equilibrium, how violently it changes once that equilibrium begins to fail. Even the kind of remnant it eventually leaves behind is in broad terms governed first by mass. The star's biography can look rich and complicated on the surface, but much of that complexity is the unfolding of one central fact established near the beginning. How much matter did gravity manage to gather into the newborn star? The obvious explanation is that a larger star simply has more fuel and therefore should live longer. That logic works for campfires and engines built on human scales. It fails for stars. A more massive star does begin with more fuel, but it also compresses its core more strongly, raising pressure and temperature and accelerating the rate at which that fuel is consumed. In stellar life, abundance often invites waste. The bigger star does not merely possess more, it burns far harder. That is why mass is not just a measure of size, it is a measure of tempo. It decides whether a star lives with patient discipline or with expensive urgency. This is where Arcturus becomes especially revealing. It likely began somewhat more massive than the Sun, not by some grotesque margin, but enough for the difference to matter over billions of years. That slight increase changes the entire schedule. A star somewhat more massive than the Sun tends to burn hotter and brighter on the main sequence, which means it moves through its core hydrogen supply more quickly. The star looks more powerful, but the cost is a shorter stable life. The achievement is real. The cost is built into it from the start. This is one of the most important reframes in astrophysics. Stellar brilliance is not just a gift, it is a rate of expenditure. When we see Arcturus as an evolved giant older in the sense of stage rather than merely years, we are also seeing the long consequences of a star that began life with enough extra mass to move more quickly toward its later transformations. The Sun, by contrast, lives in a more measured register. Its lower mass compared with stars like Arcturus gives it a longer main sequence lifetime. It burns less extravagantly. It stretches stability across a larger span of time. That relative patience is one reason Earth has had billions of years in which life could emerge. Diversify and become reflective enough to ask questions about stars at all. If the Sun had been significantly more massive, it would have been brighter, yes, but also shorter-lived in precisely the way that undermines long planetary calm. This is the larger system beneath the sky. Mass does not merely shape stars. It shapes the amount of time worlds have to become anything at all. That is why Arcturus should not be read as just a glimpse of the Sun's future appearance. It should also be read as a lesson in how even modest differences in stellar birth conditions change the whole rhythm of fate. The Sun will one day become a giant, but on a slower schedule. Arcturus has already reached that chapter because mass accelerated the path. Not enough to turn it into an extreme blue giant ending in a supernova, but enough to push it further through the standard broad arc of a sun-like star's evolution. This matters because it shows how misleading categories can be when they are too coarse. Two stars can belong to the same general family of long-lived hydrogen-burning objects and still live through that family's history at very different speeds. Mass is the hidden clockmaker. It determines how intensely fusion operates in the core, how quickly helium ash accumulates, how soon the compact main sequence arrangement fails, and how rapidly the later layers of stellar life are forced into view. What looks like character is often schedule, and schedule becomes destiny. This principle also exposes why the night sky contains so many stars in apparently stable forms. Lower mass stars spend far longer in their main sequence stages than higher mass stars do. Red dwarfs can persist for staggering spans of time far beyond the current age of the universe. Sun-like stars live for billions of years. More massive stars live faster and die younger. The sky is therefore not just populated by different kinds of stars. It is populated by different contracts with time. Arcturus belongs to a contract in which the stable chapter, though immense by human standards, was still short enough for the giant phase to arrive already. The Sun belongs to a slower contract. But slow does not mean exempt. It only means deferred. This is the deepest discomfort in comparing the two. Arcturus makes the Sun's future visible, while mass explains why that future has not yet arrived. The star above us is farther ahead in the same broad negotiation with gravity and fuel, because the terms at birth were slightly different. Once that becomes clear, stellar evolution stops feeling like a sequence of disconnected labels and starts feeling like a logic. Birth mass sets the rate. The rate shapes the history. The history determines when stability fails and what replaces it. Arcturus is where that replacement has already become visible. The Sun is where it is still hidden inside apparent calm. And that means the next layer of the story cannot be just about timing anymore. Because once mass determines how long a star remains orderly, the real question becomes what the end of that order actually looks like. Not the dramatic ending imagined from a distance, but the more important truth that a star begins remaking its system long before its final remnant ever appears. The end of a star is easiest to misunderstand when it is imagined as a single event. Human thinking likes endings that arrive on schedule, one final dramatic threshold, after which the old thing is gone and the new thing appears. A star explodes. A star collapses. A star dies. The language sounds decisive, but for stars like Arcturus, the deeper truth is more prolonged and more consequential than that. The system begins unraveling long before the remnant exists. The final object matters, yes, but by the time it arrives, most of the important damage has already been done to the old order. That is why the real ending of a star like Arcturus is not the instant when it becomes a white dwarf. The real ending is the long period in which the star can no longer remain what it was yet has not finished becoming what it will be. This in-between state is where worlds are lost, distances are redefined, and the illusion of permanence is finally stripped away. The obvious explanation is that stellar death means a dramatic last moment. The real explanation is that for stars in this mass range, death is a drawn-out surrender of structure. Once the main sequence regime ends and the giant phases begin, the star enters a sequence in which each new arrangement solves one problem only by creating another. The contracting core heats. A hydrogen-burning shell forms. The envelope expands. Later, when conditions become hot enough, helium fusion can ignite in the core, producing carbon and oxygen. For a time, this creates another interval of relative order, but it is not the old order restored. It is a shorter, more limited chapter, bought at greater internal cost. The star has moved deeper into its finite options. It is not recovering youth. It is spending the last reserves of complexity available to a star of its kind. That is what makes the late life of stars like Arcturus so revealing. The star continues to shine, continues to generate energy, continues even to appear magnificent, but its future is narrowing. The number of remaining structural solutions grows smaller, and once helium is exhausted in the core, the star cannot continue indefinitely by inventing new stable chapters forever. A star with the approximate mass range of Arcturus does not go on to fuse heavier elements all the way up the periodic table in the catastrophic chains seen in far more massive stars. That path belongs elsewhere. Arcturus is governed by a quieter law, but not a gentler one. It will eventually leave behind a dense carbon-oxygen core that gravity can no longer compress into further ordinary fusion stages. Around that core, the outer layers will become increasingly unstable and easier to shed. Pulsations, winds, and thermal instabilities can drive mass loss into surrounding space. The star does not end by keeping its greatness. It ends by losing it. This is the next reversal. The giant form so commanding from a distance is not the final triumph of stellar aging. It is the last great display before reduction. The enormous envelope is temporary. The luminosity that floods surrounding space is temporary. The expanded radius that threatens whole inner planetary systems is temporary. The star grows vast only to prove that vastness cannot be kept. In that sense, the late giant phases are both climax and dismantling. Arcturus teaches this with unusual force because it is already living inside that contradiction. It looks monumental now, but monumentality is not the future. The future is stripping. The outer layers will not remain bound forever. They will be returned to space, enriching the interstellar medium with material forged and altered inside the star across its long life. What remains at the center will be radically smaller than the giant we now admire. That is the hidden shape of the ending. Not explosion into glory, but contraction into remnant after grandeur has been cast off. And yet, even that description is too small if it focuses only on the star itself, because the star's real ending is written into everything around it. By the time the core is finally exposed as a white dwarf, the surrounding system has already been transformed beyond recognition. Inner planets may have been engulfed or sterilized. Temperate zones will have migrated far outward and then ceased to matter in the old way. Orbits may have widened in response to stellar mass loss. Atmospheres, surfaces, chemistry, and any long continuity of climate will have been broken. The star's final remnant is therefore not the beginning of consequence. It is the residue left after consequence has already passed through the system. This is why Arcturus matters more as a process than as an endpoint. The endpoint is real, but the process is where the meaning lives. It shows that endings in astrophysics are often front-loaded. The decisive changes happen before the last object appears. The star spends millions of years remaking its system, and only afterward settles into a smaller, dimmer, denser remainder. The story on the surface is that the star dies when the remnant forms. The story underneath is that the star has been dying into its remnant all along, and everything around it has been forced to live through that transition. This should change how we imagine the sun's future as well. The most important fact about the sun's end is not that it will one day leave behind a white dwarf. The most important fact is that long before that remnant exists, the solar system's familiar order will be gone. Earth's conditions will fail earlier. The inner architecture will be altered earlier. The age of planetary normalcy will end earlier. Arcturus stands as a visible correction to our instinct to focus on finals rather than transitions. It shows that the later life of a star is not one last scene. It is a long dismantling in which the apparent star remains bright while the deeper structure of its old world is being erased. And once that becomes clear, the meaning of Arcturus grows larger again. It is no longer only a future portrait of stellar aging. It becomes proof that the real cost of a star's life is not measured only in what happens to the star, but in how thoroughly its changing interior eventually dissolves the entire reality that once surrounded it. The future of Arcturus is not a larger star, it is a smaller truth. That is the next reversal. When people imagine the end of stellar aging, they often imagine a star completing its story at maximum scale, as though all the expansion brightness and giant star grandeur are steps towards some final perfected immensity. But giant phases are not a destination that can be kept. They are temporary states purchased by instability, and instability does not preserve monuments. It removes them. Arcturus is impressive now because its outer envelope has been driven outward to enormous size, because its luminosity has climbed into a regime far beyond the sun's present output, and because the star's altered surface makes late stellar life visible in such readable form. Yet none of that is permanent. The real ending is reduction. The star that now looks so expansive will not remain expansive. It will shed contract and expose something far smaller than the giant form that currently defines its identity in the sky. The obvious explanation is that stars age by becoming more and more dramatic until they culminate in their largest and brightest self. The real explanation is that late drama is often the prelude to stripping. What remains after the giant phases is not the giant made permanent. It is the core after the giant has been removed. This is one of the harshest truths Arcturus carries. So much of what makes the star visible to us now is not its lasting essence, but its temporary envelope. The vast radius, the softened orange surface, the immense radiating area, the giant star authority in the night sky, all of it belongs to a chapter that must end by being peeled away. Over time, stars in this broad mass range lose material through winds and pulsations. The outer layers become easier to disturb because they are extended cooler and only loosely held. The star is no longer compact enough to guard its own body with the old strength. Gradually, then sometimes more intensely, matter is driven outward into space. This lost material does not vanish. It expands away from the star, carrying with it the record of nuclear processing, the chemical history of the interior, and the remnants of a structure that can no longer remain whole. What is left behind at the center becomes increasingly exposed. This is the deep reduction hidden inside giant star grandeur. Arcturus is large now because the envelope still exists. Its future remnant will be small because the envelope does not survive. The core that remains after enough mass loss and enough late-stage burning is complete will become a white dwarf, a dense stellar remnant roughly comparable in size to Earth, but containing a substantial fraction of the original star's mass. This is one of the greatest contrasts in all of stellar evolution. A star that once expanded on the scale of inner planetary systems ends as an object closer in size to a planet than to the giant it recently was. The mind resists this because the reduction feels too severe. But that severity is the point. Stellar greatness is not kept. It is spent. The giant phase is not a stable identity. It is an exposed act of late survival before the structure is pared down to its compressed remainder. And the remainder no longer shines by fusion the way the living star once did. A white dwarf glows because it is hot, because it retains thermal energy from the star's earlier life, but it is not generating new power in the same ongoing way. It begins a very long cooling journey. The once dominant star becomes a dense ember, not dead in the simplistic sense, not absent but radically diminished compared with the swollen brilliance that came before. This is why Arcturus is such an important lesson in cosmic scale and false permanence. The star looks so commanding now that it tempts the imagination into thinking size and brightness are the natural climax of its biography. In reality, the climax is already inseparable from loss. The larger the star becomes in these late phases, the more exposed the fragility of that largeness becomes. The envelope is a temporary achievement. The core is the durable residue. What remains is smaller, denser, quieter, and in some ways more honest about what stellar life was always moving toward. The story on the surface is that Arcturus became magnificent. The story underneath is that magnificence was always going to be stripped away. Yet even that is not the deepest layer, because the star does not simply shrink into irrelevance. What it sheds changes the galaxy around it. The outer material driven into space becomes part of the interstellar medium, enriching it with heavier elements and altered matter that can later help form new stars, new planets, and new chemistry. In that sense, reduction is not pure disappearance. It is redistribution. The giant star loses itself, but the loss becomes inheritance for whatever forms later. This is the strange dignity of stars like Arcturus. They do not keep their greatness, yet they do not lose it into nothing. They cast it outward. The envelope that once made the star huge becomes future raw material. The core that remains becomes a white dwarf, silent proof that the old star has been condensed down to consequence. This should change how the sun's future is imagined as well. The sun will not remain a giant once it reaches giant phases. It will also be stripped, leaving behind a smaller remnant and a surrounding legacy of ejected material. The familiar star will not end as the largest version of itself. It will end as the exposed remainder after its largest version has been discarded. Arcturus reveals that pattern with unusual clarity. It shows that the most visible phase of a star's late life is often the least durable, and that the true endpoint is not grandeur preserved, but grandeur reduced to a core. Which means the final question is no longer what Arcturus will eventually become in physical terms. The final question is what that reduction means in a larger sense. Because if even a star this magnificent ends by surrendering its outer splendor and returning part of itself to the galaxy, then the real story of Arcturus is no longer only about one star's fate. It is about how endings become material for other beginnings, and how the future waiting for suns like ours is also part of the larger future of the universe itself. Arcturus is not just a warning about the future of the sun. It is a statement about the architecture of the universe. That is the larger scale hidden inside everything that comes before. A star ages, its core changes. Its envelope expands, its worlds are imperiled. Its outer layers are shed, and a compact remnant remains. Taken one step at a time, this can sound like a local biography, a sad but orderly tale of one object moving from youth to consequence. But the real meaning is not confined to the star itself. The universe we inhabit is built out of such endings. The oxygen in breath, the carbon in living tissue, the silicon in rock, the iron in blood and in planetary cores, all belong to a cosmos in which stars do not merely shine and disappear. They transform matter, rearrange energy, and then return altered material to space. Arcturus matters because it lets that larger truth be seen without needing an explosion to make the point. It reveals that even a quieter stellar ending is part of the great circulation by which the universe remakes itself. The obvious explanation is that stars are the permanent makers, while planets' chemistry and life are the temporary products. The real explanation is more severe and more beautiful. Stars are temporary too. They are engines with biographies. They generate the conditions for worlds, during one chapter erase those conditions in another, and finally release part of themselves back into the galaxy so that later structures can arise from what earlier structures could not keep. In that sense, a star is not only a source of light, it is a passage through which matter learns new forms. Arcturus, in its present giant phase, is already deep inside that passage. Its current luminosity is not just a spectacle. It is part of a broader conversion fuel into radiation order, into alterations stable structure, into redistributed inheritance. This changes the emotional scale of what the star represents. It is one thing to say that the sun will someday age into a giant phase and then leave behind a white dwarf. It is another to understand that this is not merely a private destiny for our own star. It is one expression of a universal grammar. Stars gather from gas. Gravity compresses them. Fusion lights them. Time stratifies them. Instability enlarges them. Mass loss strips them. Remnants cool. Ejected material drifts outward. New clouds eventually form elsewhere. Other stars ignite. Other planets assemble. In some distant systems, other beings might one day look up and mistake their own stable star for permanence, just as humanity once did beneath the sun. The story keeps repeating, but never in exactly the same way. That is what makes Arcturus so powerful. It is both singular and typical. Singular in its exact age, mass motion composition and current condition. Typical in the deeper sense that it is obeying rules vast enough to shape galaxies. And those galaxies depend on such obedience. A universe with stars that never changed would be a poorer universe. It would keep its hydrogen too long. It would not redistribute complexity. It would not enrich interstellar gas with the products of long stellar lives. It would not give later generations of planets access to the chemical diversity required for rocks, atmospheres, oceans, or biology. The cost of cosmic richness is that stars cannot remain in their first stable form forever. Arcturus is not failing by leaving that form behind. It is participating in the only larger economy that makes later creation possible. The achievement is real. The cost is universal. This is where the star's meaning becomes uncomfortable in the most productive way. Human beings naturally place themselves at the center of any story they can understand. So the lesson of Arcturus can be reduced too quickly to a future catastrophe for Earth, a reminder that the sun will one day render our world uninhabitable, and then move beyond it entirely. That lesson is true, but it is still too small. Earth is not only doomed by stellar evolution. Earth is made possible by stellar evolution. The atoms of this planet and the atoms of the bodies that study Arcturus were forged through older cycles of stellar birth and death, long before the Sun existed. We are not merely living under a star. We are downstream from many stars. Arcturus, therefore, speaks not only about what will be lost, but about what had to be lost before anything like us could appear at all. This is the harder balance the universe keeps forcing on us. Stability is necessary. It is not ultimate. Destruction is costly. It is also generative. The end of one structure becomes the beginning of another. The calm that nurtures worlds is temporary. The violence or dismantling that ends that calm is also part of the process that seeds future worlds. A star is a shelter for a time and then a relinquishment. Arcturus makes both truths visible at once. Its orange light still reaches Earth as beauty, but beneath that beauty is a mechanism that has already crossed out the old conditions of its own inner system and begun moving matter toward another fate. That is not cruelty. It is the rule by which the universe remains fertile. Nothing stays in the middle chapter forever. Not stars, not planets, not habitable zones, not the arrangements that feel foundational while we are inside them. Arcturus stands above us as proof that duration is not permanence, that radiance is not security, and that the universe creates its future by undoing its present. Once that becomes clear, the meaning of the star changes one last time. It is no longer only a giant, only a warning, only a preview, only a lesson in stellar physics. It becomes a visible argument that endings are not interruptions of cosmic order. They are one of the main ways cosmic order proceeds. And that means the final step in this story is no longer to ask what Arcturus is doing now or what it will eventually leave behind. The final step is to return to the beginning and see the star differently, not as a fixed orange light, but as a revelation that the slow future waiting for suns like ours is also the slow future by which the universe keeps becoming more than it was. Arcturus began this story as a light that looked permanent. That was the first illusion, and it is fitting that the final synthesis returns there, because nothing in the meaning of the star survives unchanged once the deeper layers have been seen. What appears at first to be a fixed orange beacon is no longer just a beacon. It is no longer just a giant. It is no longer just an old star, a bright star, a nearby star, or even only a preview of the sun's distant future. Arcturus has become something harder and larger than any one description. It is a visible reminder that the calm architecture of the sky is built out of processes that are never calm for long enough to deserve the word permanent. The star still shines with the same orange light. The eye still receives the same impression of steadiness. But understanding has changed the object. The obvious explanation was that Arcturus mattered because it was easy to see. The real explanation is that it matters because it reveals how deeply misleading easy seeing can be. The star looks fixed because human lives are brief. It looks serene because the violence in its history and future are hidden beneath the surface. It looks complete because the sky offers only the current chapter and conceals the billions of years of burning compression transition and loss that made that chapter possible. Once those hidden layers are restored, Arcturus stops being scenery and becomes truth exposed. The first truth is that stability is expensive. Stars do not remain bright by possessing some eternal reservoir of order. They remain bright by spending themselves with extraordinary discipline. The long middle age of a star is not a permanent achievement. It is a managed depletion. The sun feels dependable for the same reason Arcturus once felt dependable, because hydrogen fusion in the core sustains a truce with gravity that can last for billions of years. But a truce is not a victory. It is a temporary arrangement between opposing forces, and time always changes the terms. Arcturus has already crossed beyond the terms that define the Sun's present life. That is why it matters so much. It lets us see that even the most stable stars are not preserved by their steadiness. They are slowly transformed by it. The second truth is that enlargement is not safety. Arcturus became more luminous, more expansive, and more visually commanding. Not because stellar life had entered a superior and permanent fulfillment, but because the old interior order had begun to fail. The giant phase is grandeur under pressure. A contracting core and a swollen envelope do not describe perfect maturity. They describe a star surviving by different means because it can no longer remain what it was. What looks majestic from far away is at a deeper level a sign that the simple architecture of youth and adulthood has been broken. The third truth is that a star never changes alone. Arcturus is not only a biography of one object, it is a system-level event. When the star's luminosity rises and its radius expands, the meaning of every nearby orbit changes with it. Whatever worlds once lived under the calmer geometry of its earlier life would face a different sky, a different thermal reality, a different future. This is what makes the star's relevance feel uncomfortably close. The Sun will not simply become different in isolation. It will eventually change the terms of existence for everything bound to it. The age of Earth as a life-bearing world belongs to a limited chapter of solar history, not to some everlasting contract. Arcturus makes that truth harder to ignore because it shows the later chapter in visible form. The fourth truth is that endings are reductions before they are remnants. By the time a star like Arcturus leaves behind its white dwarf core, the real ending has already happened in slow motion. Worlds have been altered. The envelope has been loosened. Mass has been shed. The old order has already been dismantled long before the final compact object remains. The white dwarf is not the beginning of consequence. It is the residue after consequence has passed through the whole system. And the final truth, the largest one, is that this loss is not only destruction, it is inheritance. Arcturus will not keep its outer splendor. It will return part of itself to the galaxy, and the galaxy will use that returned material in later generations of stars, planets, and chemistry. The universe keeps moving forward, not by protecting every stable form, but by letting stable forms end and then building with what they leave behind. That is the full transformation of the opening image. Arcturus no longer means permanence, it means process. It means that what looks fixed is often only slow. It means that what looks calm is often the surface of expenditure. It means that beauty in the sky can be the visible skin of deep structural change. And it means that the future waiting for suns like ours is not an exceptional tragedy reserved for one distant time and one particular star. It is part of the general rule by which the cosmos exchanges stability for renewal. This does not make the future gentler. Earth will still belong to a temporary interval. The Sun will still carry a deadline inside its own light. The world's near-aging stars will still pay for the transformations of the stars they orbit. But it does make the story larger and more intelligible. We are not witnessing some isolated cosmic sorrow when we look at Arcturus. We are witnessing a chapter in the same vast circulation that made our own existence possible. The star overhead is ancient enlarged and already committed to a future beyond its present grandeur. So, in the end, Arcturus is not best understood as a giant star hanging above Earth. It is better understood as a revelation that even the most reassuring lights in the sky are temporary arrangements, and that the slow future waiting for suns like ours is already shining above us now, disguised as something steady enough to seem eternal. What Arcturus finally reveals is not just the fate of one star, but the true scale of reassurance itself. The lights above us feel permanent because human life is brief, because generations pass while stars seem to hold their places, because the sky offers continuity in a universe otherwise full of loss. But Arcturus breaks that illusion without any need for violence or spectacle. It stands there in steady orange light and shows that even the calmest radiance can be the visible surface of deep internal change. A star can look serene while already living beyond the chapter that once made stability possible. That is why Arcturus matters so much. It turns stellar evolution into something almost legible to instinct. It shows that suns do not remain suns forever, that habitability is a phase rather than a guarantee, that luminosity can be a symptom of structural upheaval, and that the future of a star is written inside the very process that makes it shine. The sun carries that same logic, now hidden beneath the familiar comfort of daylight, not as an immediate threat, as a built-in future. And yet, the lesson is not only loss. Arcturus also reveals the strange generosity of endings. A star spends itself, expands, sheds contracts, and leaves behind both a remnant and a legacy. What it cannot keep, the galaxy eventually uses. Matter passes onward. New stars form. New worlds assemble. New intervals of calm appear under other skies. So the deeper meaning of Arcturus is, this permanence is not the rule of the universe. Transformation is. The star we began with as a fixed beacon becomes in the end a far more powerful thing, a visible proof that the slow future waiting for suns like ours is not an exception, but part of the great ongoing exchange by which the cosmos keeps remaking itself.